Okay, so my first video didn't work, which stunk, so I made it too long and then it didn't want to copy over to YouTube. So here's my next try for Chapter 4, Heat and Work, and we're going to work through the word problems, number 21, 22, 23, 24, 25. We'll probably do 21, 22, 23 on this video, and then 24, 25 on the second video. So problem 21, if you have 80 BTUs of heat energy and they're added to 2 pounds of water at 40 degrees Fahrenheit, what will the final temperature be? And so the key information, we have the 80 BTUs, the 2 pounds, and the 40 degrees Fahrenheit that we're going to be working with. And so I've actually already laid out the problem. And so what we have here is the question itself, 21, and then we're going to be using change in temperature, which is equal to Q divided by the mass times the specific heat. Some of the info I had to look up was the specific heat of water, which is 1 BTU divided by a pound degree Fahrenheit. The start temperature from the word problem is 40 degrees Fahrenheit, and the Q is 80, and the mass is 2 pounds. So then I'm just placing it into my equation. So I have my BTU, which is my Q, and I have my mass, and then I have my specific heat. When I plug them all in, 2 divided by 80 is 40 degrees Fahrenheit, and crossing out pounds from pounds and BTUs from BTUs, all I'm left with is degrees Fahrenheit. And then I'm going to take my initial temperature plus my change in temperature will give me my final temperature, which happens to be 80 degrees Fahrenheit. So that's question number 21. Now we're going to work on 22. All right, so question number 22, how many BTUs of heat energy are needed to raise the temperature of 12 gallons of water from 50 degrees to 130 degrees Fahrenheit? How much would this cost in electricity of water if the cost was 8 cents per kilowatt? Alright, so there's a few steps to this problem, and to start out with, the equation I'm going to use is Q is equal to the mass times its specific heat times its change in temperature. And remember that whatever your specific heat units are, all the other numbers, like the mass and the change in temperature, have to change to that same unit. So we're going to be using the specific heat of water here, and that has the unit of BTUs, pounds, degrees Fahrenheit. So I have to change the 12 gallons of water, my mass, in the problem, to pounds. So the first step is to take my 12 gallons and times that by 8.3 pounds over 1 gallon. Gallons are going to cross out, so gallons, gallons. And what I get when I times 12 by 8.3, I get 99.6, and my unit is pounds. So now that I have that in pounds, I can begin by placing it all into the equation. So I have 99.6 pounds. That's going to be times by my specific heat of 1 BTU over a pound over a degree Fahrenheit, and that will be times the change in temperature, which is 130 degrees Fahrenheit minus 50 degrees Fahrenheit. For units, Fahrenheit is crossing out and pounds is crossing out, so my answer will be in BTUs. So I'm going to subtract the 130 minus the 50, giving me 80 degrees Fahrenheit, times 1, still 80 degrees Fahrenheit, times 99.6, and I get 7,968, and that's in BTUs. But I want to solve for kilowatt hours, and so the next step that I need to do is convert the BTUs to kilowatt hours. I'm going to look that up on the table in the book. So that's a conversion. We practice conversions in class. And when I look up that info, I get the equivalent of 1 kilowatt hour is equal to 3,413 BTUs. So I'm going to divide this number by 3,413. That's a BTU over kilowatt hour. My BTUs are crossing out. My answer will be in kilowatt hours. When you times that up, you're going to get 2.33 kilowatt hours. Now, the next step is the money amount, and it's 8 cents per kilowatt hour. So I'm going to times this by 8 cents per kilowatt. Kilowatt hours is going to cross out. I'm just going to get a money amount. And when I times this, I get 18 cents. It's going to be 18.6. It's 0.186, and I'm going to round up and make it 0.19. And that's the amount. Now this is a real world problem, because we're talking about amount of water needed, and we're heating it up to 130 degrees, and this is like taking a shower. So you take a shower and you use 12 gallons of water over here, and as you're taking that shower, and you're heating that water that's coming in the house at 50 degrees up to 130 degrees. How much does it cost you to take that 12-gallon shower? Well, about 19 cents. If you're getting a number that's like in the hundreds or $200, something ridiculous like that, think about it. Does it cost you $200 to shower every day? No. So these problems should make sense. They're real world problems. So think about the numbers as you're working through them. It should be logical. All right, we're going to work on question 23, and electric energy in kilowatt hours is needed to heat water in a well-insulated electric hot water heater with a capacity of 40 gallons. So the hot water heater holds 40 gallons. And you're going to heat it from the 20 degrees Celsius that it enters the house to 50 degrees Celsius. Or, if you want to use Fahrenheit, 68 degrees up to 122 degrees Fahrenheit. Alright, so since this is a real-world problem, I'm going to be solving for Q because we want to know thermo and electric energy. And once again, my specific heat, I'm going to be using the BTU specific heat. So I'm going to be using this set over here with the 1 is 1 BTU, about a degree Fahrenheit. And my change in temperature, because it's in Fahrenheit, I'm going to use the 68 up to 122 degrees. And the gallon tank, the hot water tank, is 40 gallons of water. Some of the other info I needed was conversion from gallons to pounds and conversion on kilowatt hours to BTU. And so I already wrote out, I have my 40 gallons, and that's going to be times the 8.3 gallons over a pound. Gallons crosses out, and I'm left with pounds, and I get 332, and that's pounds. Then I'm going to plug it into my equation above. This equation above, I do it down here. So this is my mass, this is my specific heat, and this is my change in temperature. My Fahrenheit's crossed out, my pounds crosses out, and my answer is left in BTUs. And I get 17,928. Now I'm going to convert that to kilowatts. So I take my 17,928 and I divide it by 3,413, and that's BTUs over a kilowatt. BTUs crosses out, and I'm left with my answer in kilowatts, and I get 5.25 kilowatt hours. I rounded up to the 5 here. So this is the first part video, and I'm about to make part 2, which will be questions 24 and 25, which have a lot more steps, and I know that.